Hello everyone. I hope you all are doing good. Let's start the another interesting topics of WebRTC tutorial series. Today let us continue the implementation of our first WebRTC chat room application. In this video, we are going to see the client-side WebRTC implementation. I hope you already watched the part 1 video of server-side implementation of this chat application. If you are not watched yet, please go and watch that video, because the server-side understanding is required for the implementation of client-side. First of all, welcome all to Engineering Semester channel. Here we are providing new emerging technologies tutorials. If you are new to this channel or new to this WebRTC series, please go and watch our introduction part first. Now let's get into it. Before going to implement the client-side application, let us quickly see how this chat room application will works in the browser. We can see the demo of the application now. Once you open the HTML page, you can able to log in to the server with random username. Now we can log in as two usernames with two tabs of HTML page. After login, you can see the online user list in the left side. We have logged as test user 1 and test user 2. So the test user 1 can see the available user for chatting is test user 2. If you press the username, you can see a pop-up will come and ask for the chat request. You can see in another side, a pop-up will come with answer or reject button. Once you accept the answer, you can able to chat with other user. This is achieved by WebRTC data channel. Now you can send messages between user 1 and user 2. All the messages will be handled by WebRTC technology. Finally, if user want to leave from the room, they can click the leave room button. I hope you understood now how this WebRTC chat application going to work. Now we can implement the client-side application step by step. I would like to explain each steps of the client side in high level, so that you can get a real picture of this WebRTC application. Let us start the implementation. We already decided that we will use HTML and JavaScript for client-side application. If you want to create a web page, simply you can choose any of the HTML template. JavaScript allows us to add dynamic behavior to the web page and add special effects to the web page. First, let us see how can we write a simple HTML web page for the application. One thing I want to say, we are not going to write different HTML pages for login and chat room. We can achieve those functionalities by writing one HTML page with different divisions. So let us look how can we write that. I have written a simple HTML file and named as index. In this page, I have added head and body section. You can include required scripts, font and bootstrap related files in the head section of this HTML file. In the body section, I have added 3 divisions for the user login, user area and user chat area. We can control the display of those divisions by using JavaScript. Finally, I have added 2 bootstrap modal area for showing pop-ups. Next, we can move to JavaScript logic of this HTML page. We have created JavaScript file and named as chat app. I hope you all remember that we have created a WebSocket and Node.js server. In client side, we have to use that WebSocket connection for communicating with server. Once the connection is successful, WebSocket will call on open callback. In the server implementation video, we have discussed about ping-pong mechanism. I hope you are remembering now. If you are new to this concept, please go and watch that video for the understanding. Client has to send a ping message to server, and server will send pong message back. To do this concept, in WebSocket on open callback, we can send ping message to server. We can use setInterval function to wait for some time to get the response from the server. Once server respond back for the ping message, we can reset the timer. we have written a ping function to send the ping message to server. In this function, with the help of connection.send method, we can send message to server. Here you should remember, we are sending ping and pong messages without JSON format. If we did not receive the server pong message back within the time interval, then we have to show the server down error to client. All the error handling we are updating in the populate error function. Suppose if you are in the login screen and the timeout happens, then we have to show the error message to user. If the WebSocket has any connection error, then connection on error callback will be called. In this callback we can show the server down message to user. If the WebSocket has received any message from server, then the connection.onMessage callback will be called. Suppose the server respond with pong message, we have to clear the old timeout. We can use pong function to do the timeout clearance. If the user is in login page, then they can use random username for login. Once user type the username and press login button, then the username has to be sent to server for validation. To send the username, we have to use login as type field. This will ensure the server can recognize login request and do the validation. If the login is success, then server will send back the message to client with type field as server login. Client will use onLogin function to handle the server response. If the server send false in the data field of login message, this means same username has been exist in the server. Now we have to show error message to user like username already taken. If the server sent true in the data field of login message, that means client has successfully logged to the application. Now we are ready to show the user screen, and also we have to hide the login page. To do that, we can use the attribute display as none. Finally, we can make the logged user as online. If another user has logged to the server, then server has to send the user list to all the existing users. Server will send the user list as a JSON message with map data structure array as data. First, server will send a message to each of the user with a type field as server user list. Client application will process the user list message in the load online user list function. In the map data structure, server will add username and user status as key and value. So client has to first extract the username list. One important thing we have to remember here, server will send all the username existing in the server. So we have to remove our username from that list and show the other username in the online user list area. Once we extracted the username from the JSON message, then we have to create a dynamic HTML code for displaying the online user list. This can be done with the help of a for loop. When the user click on the online user list, then we have to process the chat room request. And finally, we can update the user status of each username with the help of update user status function. Once we created the online user list, then next we'll be handling the click events. If user clicked the username of online user list, then we have to send a request to server for the chat room. As of now, we did not created any WebRTC connection. Once user clicked the username, client has to send a message to server with a type field as want to call. Once the server received the request, the server will check the peer user status and send response back with type field as server already in room. Check user status function will handle that response. In the check user status function, first we have to check the status response from the server is true or false. If the response from the server is true, that means requested user is busy. If the response from the server is false, that means user is available and can accept the offer request. If the user is available, then the next step will be, we have to show an outgoing request pop-up window for showing the progress of the room request. To do that, we are using create pop-up notifications function. This function will create a dynamic bootstrap modal to show the pop-up with progress text. We can add CSS style to customizes the pop-up also. Once the dynamic HTML code is created, then we can show the pop-up using jQuery method. Now we have created the pop-up with the progress text. We have set a time interval 10 seconds to show the pop-up. During this time, we have to create the RTC peer connection object. WebRTC connection object will be created inside the create WebRTC initial connection function. First, we have to set the ICE connection. To do that, we have to add stun and turn server names. I have selected some free Google stun and turn server. After you define the configuration parameter, you can create the RTC peer connection object with the help of RTC peer connection API. After the creation of object, we have to register the ICE candidate event state change and handle on negotiation callbacks with that RTC object. ICE candidate is mandatory, and other callbacks are depends on your use cases. I have defined those callbacks also, but I am not going to use in this chat application. In the ICE candidate callback, client will send the ICE candidate to signaling server periodically. Also, this callback will taken care if there is any updation of ICE candidate required in between. After the WebRTC connection, next, we have to create the data channel. I have written the creation of data channel inside the create data channel function. We can use create data channel API function to create the data channel. You can set the data channel options based on your requirement. Here I have set the basic options. I have created the data channel name based on the peer user name. You can customize the name accordingly. Here I am just created the data channel object name as send data channel. Once you create the channel object, you have to register some callbacks for listening the incoming request. These are the major callbacks we are going to use for data channel. If any error occurs, then on send channel error state callback will be called. If any text message received, then on send channel message callback will be called. Once data channel open, then on send channel open state callback will be called. Finally, when the data channel is closed, then on send channel close state change callback will be called. As we said earlier, in the send channel message callback, we can get the user messages and we can display in the HTML chat page. To do that, we are using update chat messages function. Here event.data will contain the text data from the user. Other Boolean value is to represent the client-side message. Based on that Boolean value, we will create a dynamic HTML code to display the user icon and text message. After the creation of WebRTC peer connection object, we have to create the WebRTC offer for the peer user. To do that, we are using creating offer function. In this function, I have created the offer and set the local description as that offer. Once you set the local description, you can send this offer to peer user with the help of signaling server. To send this offer to server, we can add a type field as offer and data as offer in JSON format. Once the server receives this offer, server will send this offer to peer user. If there is any exception or error happens, then we can clear the pop-up and notify to user with an alert. Now we send the offer to server. In peer side, we have to receive this offer. Server will send this offer to user with a type field as server offer. To process this offer, in peer side, we have to call on offer function. When server send this offer to peer user, then client application should show incoming pop-up. To show the incoming room request, we have to create another Bootstrap modal pop-up with accept the offer or reject the offer button. Creation of this pop-up is handled in the create request room modal function. This function will create a dynamic HTML code for modal pop-up with accept or reject button. When you click accept button, then make answer function will be called. If you click reject button, then reject answer function will be called. When you click the accept offer request in the pop-up, we have to create the WebRTC answer for that offer. To do that, in the peer user side, we have to create the WebRTC peer connection first. We have only created in the user side before. We can use the create WebRTC initial connection function. In the peer side, we don't want to create any new data channel. Since other user already created the data channel, we can just use on data channel API to get the message. Now we can set the remote description of the RTC object with the client offer. Finally, we can create the WebRTC answer with API. Once you created the answer, you have to set this answer as local description of the peer connection. After that, we can send this answer to signaling server with type field as answer. If there is any exception or error, we can clear the pop-up and notify the user with an alert. Now we have sent the answer to server. So server will send back to the client user. Once the server send the answer from the peer user, we have to set the remote description in the client side. In the onAnswer function, we can set the remote description with that answer. In between, if we receive the ICE candidate request from server, we can call onCandidate function. In this function, we have to add ICE candidate for the peer connection. Once you set the answer, then we are ready for the chat room. Finally, we have to send the ready message to server to start the room. You can use ready as the type field for sending message to server. Once client send ready message to server, then server will send ready message back to both the users. When client user received the ready from server, then we have to remove outgoing pop-up. On the other hand, peer user received the ready from server, then we have to remove incoming pop-up. Finally, we can display a message as success, and also we have to set the user status as busy to avoid other offer request. Then user can send messages to each other by activating the chat window. Suppose if peer user doesn't want to accept the chat request. Then peer user can click the reject button of the incoming pop-up. This means peer user rejected the offer request from client user. We can handle this scenario in the reject answer function. In this function, peer user will send busy message to server with busy as type field. Once peer user send busy message, server will send back to client user with a message like user is busy. Now client can handle this condition in busy user function. In this function, when user is busy, we have to clear the outgoing pop-up and display a message like user is rejected the request. Also, we have to delete the WebRTC connection object. Object removal can handle in the delete WebRTC connection function. If any data channel created, then we have to close that data channel also. Suppose peer user has accepted the offer and created the answer, then both user can send messages each other. In the send message function, we are displaying the text messages. Using update chat messages function, we are creating the dynamic text in the HTML page. In the peer user side, we can get the text message from onReceive channel message callback function. Once we get the text messages, we can call update chat messages function to displays in the HTML page. If any of the user want to leave the chat room, they can click the leave room button. To handle the scenario, we are using leave room function. In this function, user will send a leave request to server with type field as leave. Next, server will send message back to each of the user for the closure of the chat room. So each user has to handle this case in the dispose room function. In dispose function, user has to delete the WebRTC object and hide the chat window. Suppose both user is in a chat room. Suddenly one user has closed the browser window. In this case, we have to notify to other user like peer user has been quit from server. To handle this scenario, server will send a server exit type field message to the user who is in the chat room. So that user can close the chat window in the left from server function. Here user has to delete the WebRTC object and hide the chat window. We hope you got a complete understanding of the chat room client-side implementation. We have provided the GitHub link in the description of this video. You can feel free to download the code and go through line by line. You can check both server and client-side application together. In between, if you have any query, please comment in comment section and we will try to answer the question as earliest possible. I would like to say, this is a basic chat room application using WebRTC. You can customize this chat room and you can add new ideas. I hope your patience is rewarded here. That's it for now. If you are thinking this is informative, then like and share, subscribe. Also support us. See you soon with another video. Thank you. Have a wonderful day.